Hi, so here we are today. Our goal is to be able to solve real-world word problems involving cones and cylinders. So go ahead and pause and write your objective down. All right, so some of the things we need to consider as we're working through each questions and problems are: what information are we given? What formula do we need to use? Is it the cylinder formula? Is it the cone problem? And does your solution make sense in the context of the situation? A lot of times with a lot of these program problems, we will need to do something after just following the volume of the cone or the cylinder. So we have Victoria bought coffee shaped like a cylinder. So I'm going to circle that word cylinder because I know that it's a cylinder with a radius of 5 centimeters and a height of 15 centimeters. She fills the coffee cup but leaves 4.5 centimeters of space at the top to have room for cream. What is the volume of the coffee in her cup to the nearest tenth? So, we know that what we know here is that the radius is 5 centimeters. The height is 15, but she leaves the space of 4.5 centimeters. So we need to know the volume of coffee, not just the volume of the cup, but the volume of the coffee. So we first need to know, we're looking at the volume of the cylinder. So our formula for the volume of the cylinder is pi r squared times the height. It's that area of a circle times the height. So we have pi r squared times the height. If you have a height here, but let's draw a quick model of this coffee cup. And when I mean quick, I mean quick. So we know this whole height is 15, but it says she leaves this much room, and let's call that 4.5. So we can't just use the height of 15 in our formula. We have to find out what is 15 minus 4.5. So we can subtract that. We're going to get 10. We get 5. Bring our decimal down. 4 minus 4 is 0. 1 minus 0. So you get 10.5. So our new height there is 10.5. So now we have pi times 5 squared times 10.5. So then we're going to get 25 squared, or 5 squared is 25, times 10.5 times pi. Now, when you multiply that all out, you may have to use the Desmos calculator on these, or you're going to get a slightly different answer. You get 824.7 centimeters cubed. So depending on whether you used 3.14 or the pi button on Desmos, you're going to get a slightly different answer. I would encourage you all to start getting familiar with the Desmos calculator and using that pi button. But your final answer is 824 824.7 centimeters cubed. All right, moving on. A tea vendor gives samples of a tea cone-shaped cups. The cups have a diameter of 4 inches and a height of 5 inches. If there are about 5 fluid ounces in 1 cubic inch, how many fluid ounces of tea will a sample hold? Round to the nearest tenth. So, what we know is that it is a cone-shaped cup. A cone-shaped cup. Our diameter is 4. And the height, our diameter is 4. Our height is 5. And then we have 0.55 FL in a cubic inch. So we actually have to do something else after we find the volume here. We need to know how many fluid ounces are in the cup. So we need to go ahead and find our volume, which our formula for volume is 1/3 times pi r squared times the height. So we can just go ahead and plug that in, which plugging in our radius, we know our diameter is 4, so our radius is going to be 2. So we'll have 1/3 pi 2 squared times our height of 5. When we plug that all into the calculator, we should get a volume of 20.9. And then we have to find out how many fluid ounces are in the cup. So we just need to go ahead and multiply that 20.9 times 0.55. And we get the solution we need, which is 11.495 fluid ounces. But in this case, fluid ounces. In this case, they told us to round to the nearest tenth. So we look at our tenth, we go 1 over. If it is 5 or more, we add 1 to our tenth place. In this case, 9 is 5 or more. So we have 11.5 fluid ounces as our final rounded answer. All right. Tess orders a snow cone in a cone-shaped container. The container has a diameter of 3 inches and a height of 5 inches. If snow costs 20 per cubic inch, how much will her snow cone cost? So this is very similar to the last one. You need to find the volume of the cone and then multiply it by the cost of the cone per the snow cone, the snow in her cup. A cone has a volume of 7,065 inches and a height of 30 inches. What is the radius? And this one specifies using 3.14 for pi. So we know when we get to that step, we're actually going to use 3.14 and not that pi button. So when we have volume already, we're going to write our volume of a cone, which is 1/3 times pi r squared times 30. So we're going to go right into volume is 7,605 equals 1/3 times pi r squared times 30, because that's what we have. We have all that information. So now we are going to multiply everything that we have. So we have 1/3, we have pi, which they said to use 3.14. So we're going to actually use 3.14 here for pi, times 30. So we're going to do 3.14 times 30 times 1/3, which gives us 31.4. And then you have r squared. So you're just going to, now we've used this, and pi, we've used this. So you're just going to bring down the r squared, and then 7,065 equals 3.14 r squared. Well, then we just solve it like we would a normal equation. 314 divide by 3.14 divide by 31.4. And it's 31.4, not 3.14 there. And you get 225 is equal to r squared. So now you need to know what times itself equals 225. So you need to know the square root of 225 is equal to r, and the square root of 225 is 15. So r is equal to 15. A swimming pool is shaped like a cylinder with a radius of 15 feet and a height of 6 feet. If 1 cubic foot holds 7.48 gallons of water, how many gallons of water can the swimming pool hold? So this is very similar to the other ones you've done. So I'm going to have you pause and try and figure out this one for yourself. A cylindrical cooler, so cylindrical means cylinder, has a diameter of 30 inches, a height of 20 inches. Runners in a marathon used a cone-shaped cups to get a drink from. If the cups have a diameter of 3 inches and a height of 4 inches, how many full cups can be used from the puller? Estimate using 3.14 for pi. So we have to use 3.14 for pi here. Alright, so we have our first thing we need to do is find our volume for our cylindrical cooler. So we have V. V is equal to pi r squared times our height. So we have V is equal to, our diameter is what we have here. So we have to do 30 divided by 2 to find our radius. It's going to be 15 squared times our height of 24. When we multiply, and we're going to use 3.14 for everything because that's what it tells us to do. So our volume is 16,956. And then we're going to do the same thing for our cone. Our cone-shaped cups have a volume that is going to be 1/3 times pi r squared times the height. So when we plug in our volume formula, we have pi, we get r squared, which is going to be 1.5 because it's half of the 3. 3 divided by 2 is equal to 1.5. And then times 4. And we're going to square that as well. So we get the volume of our cones is going to be 9.42. Now we got to go back up and read our question. We have our volume of our cooler, and we have our volume of our cones, our cups. We need to figure out what the question is asking us. How many full cups can be filled from the cooler? So we need to figure out how many times can this fit into this. So we are essentially trying to find 9.42 times what, times the number, we're going to call it x, is equal to 16.95, or 16,956. So to solve that, we're going to divide 9.42 divided by 9.42. So you get 16,956 divided by 9.42. And it's going to equal approximately 1,800 cups. So you're going to get approximately 1,800 cups from your cooler. That's how many cups you could fill up. Alrighty, go ahead and write your summary and hit pause and have a great day.